Hello, welcome to Earth Engine tutorial episode 46. In this video, I'm going to show you how to use locally trained machine learning models with Earth Engine. So the idea is that if you already have some model trained locally, you don't really have to do that repeatedly using Google's engine. So you can basically save your locally trained models and directly converted models to Earth Engine format. Then you can directly use it for classification, so without having to repeatedly go through the training. With that being said, let's get started. So we are going to first download the notebook example we're going to use for this tutorial. So you can go to the GMap homepage, and then from there you can click the GitHub icon. I'm going to show you here on the left side. You can also see the notebook from here, number 46. If you click here, you can see the text. So this one loads much faster than a GitHub, but we're going to use the original one. So let's click right click the GitHub icon, and then from here click examples notebooks. Scroll down to find number 46, and then you can click the lower button. Right click save as. You can download that one to your local computer. So I'm going to download this one to my downloads folder, and once you hit save, then you should be able to see this one right now already saved to local computer. And let me move this one here. So next I'm going to open the terminal. If you're using Windows, you can open Anaconda prompt. So once you open the terminal, you can activate the Conda environment. So Conda activate GE, and then just type Jupyter notebook. So it will open on your browser. So, and then once it is open, click the notebook. So here we are. If you don't have Jupyter or the GMap installed on your computer, then you can open in Colab to run this one in Colab. It should work as well. So first, let me just clear all the outputs so that we can start from scratch. And so first of all, I would like to thank Kale Market for contributing this notebook example, and also the machine learning module. So this was originally developed by him, and then I make some minor improvement to the notebook. So let's get through this by each section. So first of all, we're going to import the libraries, and keep that in mind. So the GMap Python package does not have the scikit-learn dependency, so make sure that you install this one by Control/ to uncomment this line, and then you can install the package. So I already installed the package, so I just want to comment out. And next, once you install the package, then we can import the libraries. We need Earth Engine and also GMap, also pandas, and we also need the machine learning module. If you want to learn more about what's available in the module, you can go to the GMap homepage, and from the API reference on the left side, you can see the ML module, and you can see some of the functions available for this one. If you want to look at the source code behind, so you can click and to look at the source code behind each function. Let's get back to here. Okay, so import the library, and also you need to initialize because we need to use Earth Engine. So click one, and once we import the libraries, then we can start training the model. So in this example, we're going to use a CSV that is on my GitHub repo. So if you can go to my GitHub repo, I can show you where it is. So under the examples folder, there's another data folder, and this is the one here, this CSV RF example doc CSV, and you can see from the table in here we have multiple columns. So B2, this is for lane set 8, right? So it's for blue, green, near infrared, and also shortwave infrared. And we also have the other column called lane cover. So In this tutorial, we're going to basically classify the image into 3 classes, and I'm going to show you shortly. So first of all, we're going to download this one. As you can see from here, we can define the link to the CSV, and then we can use pandas to directly read the CSV. So it's going to download the data and then open the data. So just execute, and then we can look at the data. So it's going to print the first 5 rows and also the last 5. And so in this CSV we have I think 98 rows. If you scroll down, total of 98, right? And so next we need to split the data, because when we need to use this for machine learning, we need to figure out which columns we're going to use for the features, and which column is the label. So the label basically is the class we want, right? And so this can be seen as the predictors, and this will be the outcome variable. So, and once we execute this one, this is just basically telling the program that we want these 6 columns as the features, and the last column, the name, is the class. And so once we define it, we can use the pandas to select the columns. So basically it's going to select all these columns as one variable and select the last column as the other variable. So this will be X, capital X, and also Y. Let's execute. Next, we can set the classifier. So in this case, we're going to use the scikit-learn ensemble classifier. So it comes from here. And so we're going to use the random forest. You can also use decision tree. So because they're all ensemble, so it's you can use either one. Those are the one that will be you can convert to Earth Engine. You won't be able to do other classifier, for example, support vector machine or others, because those you cannot actually convert to Earth Engine. So ensemble random forest classifier and the number of trees. So this one, it's basically if you're doing random forest, the default the number of trees is 100. You can decrease this to a smaller number, or you can increase to a larger number. It's up to you, but keep in mind you don't want to have a huge number, because later when we're trying to convert this one to Earth Engine classifier, if the string is too long, so it's going to fail. So 100 is a good number. And then you can fit X and Y. Once you have this one, we're going to have a classifier. Then we can convert this one to Earth Engine. So let's execute first. And so this one is a random forest classifier, but we need to convert this one to a list of strings first. Otherwise, you cannot directly convert this one to Earth Engine. So what we need to do is to call this function, machine learning module within GMap, and then call the function called rf to string. So random forest to strings. If you want to see the source code, you can come back to the GMap homepage. Then click this one here, random forest to a string. And if you want to look at the source code, again, you can look at the source code in here. And it's a short, not many lines of code, but it's called other functions. So for example, where is it? So a string to classifier. So for example, there are lots of functions in here. You can look at the source code if you want. And so let's just execute. Once we convert this one to a string, so now basically it's a list, and then we can print out the items within the list. For example, we can print out the first tree. As we mentioned earlier, the number of trees is 100. So in this case, the list is going to contain 100 items. So if we use the index 0, it will be the first item. So this is what it looks like in the random forest, the first tree. So random forest basically is on ensemble of trees. So you have a lot of trees, and this is the first one. So you can see that from the top to the bottom. So it goes through one by one. So this is all the conditions. I don't want to get into the detail, but you can just think about each each tree is one decision. So when you have a pixel value, we have each location, each pixel has 6 values, and it's going to pass through this tree one by one until you get to the bottom, and then you can classify which class. And if you have 100 trees, you can at the end going to do the voting. So which class ever get the most votes, you'll be assigned to the specific class. You can print out the second one, so we can print out one by one, but that's enough for now. We just look at the first 2 trees. You can also have a condition here to check whether, because earlier we said 100 trees, and at the end, once we convert that to a string, we also want to make sure that it's the same number of trees that we set out. So this is true, means we are good to go. And so the next step is now to convert this list of string back to Earth Engine classifier, and then so we can move into the next steps. As you can see from here, we use a data function called strings to classifier, right? So basically, from the random forest, the scikit-learn classifier to an intermediate format is a list of strings, and then from the string to Earth Engine classifier. So there's multiple steps are involved in here, and we can execute. You can control slash to look at this one if you want. So if you look at this one in here, right, this is still a list of strings, but it's basically a dictionary. So within here, this is like one by one. So essentially, you're going to have 100 trees at the end. But it's too complicated for this one, so we don't need to look at this right now. And so once we have the classifier, this one right now becomes a cloud computing objects. So then you can use this one to do image classification using Google's engine. Okay. And so because the data is for Landsat 8, we're going to apply the classifier to Landsat 8 imagery. So in this case, we're going to use the T1, the raw imagery, and this is the entire image collection. And we're going to filter the imagery to create a mosaic or a composite. So this is what we're going to use from the year 2018, okay, from January 1st to December 31st. And you can see from here, this is like global scale. And so we're basically trying to classify the global Landsat 8 imagery for 2018. And so this is the imagery we have. This is the variable. And once we have the variable, we're going to select the imagery because the Landsat 8 contains more bands than we need, but we only need those 6 bands that we're going to use for classification. So B2 to B7, as you can see from here, we only select those bands that are necessary to do classification. And once we select the imagery, basically this is a subset of the imagery, and then we can do classify. So we pass in the classifier that we converted from a list of strings from the step above. Execute. Oh, we need to execute this one first and then execute this one. So once we have the image classifier, then we can add this one to the map so that you can display and do the comparison. And so first we're going to create an interactive map, then we're going to add these 2 layers to the map. And let's take a look. So by default, we set the zooming location here near California, so you can zoom out if you want, and you can uncheck this one. So right now we only have 2 data layers. So the first one is the original raw data. So this is Landsat 8, the composite, the simple composite. Looks pretty nice, right? You can see here pretty clean. It should be, depends on the location. You can zoom out, zoom into other location, and the data should load like a few seconds, right? So then you can look at the classified imagery. So in here we classify into 3 classes: water, vegetation, and impervious surface. So basically urban area or developed area. Just for demo purposes. In reality, you might want to have more classes. So, and if you have training data from with more classes, you can classify as more classes. Okay, so this is what we have. So the steps that we just went through, basically, you train your model locally using scikit-learn, and once you get the model, you convert the model to a string, a list of strings, and using this intermediate format, we can convert the strings to Earth Engine classifier, and then we use the Earth Engine classifier to do supervised classification. Okay, so next I'm gonna show you, like, because once you classify, you already have the classifier. You might want to save this classifier so that you don't have to retrain the data. In this example, because the classifier is pretty simple, so it just take a few seconds. But if you already train on a large data set, you might want to just save the classifier rather than have to retrain the data every time. So the last two steps shows you how to save your classifier, and the first one is to save to the cloud. So first of all, you want to define, because we're trying to automate the process, so the first two blocks trying to figure out what's your user ID. So if you see from here, it's going to automatically figure out your user ID, depends, because you already authenticate, so we can automatically retrieve your username, and then within your username, we're going to get asset ID. So this is the one that we're going to save to your Earth Engine account. You can change the name here if you want. So essentially, this will be the assets ID official collection going to save to your account. And so the ID, this is the export to the official collection. So you want to uncomment this one, control slash. We are trying to export this one as a official collection to your account. The tree, if you go back to here, where does that come from? It's from here. So this is the one that basically, this is the intermediate format that we used earlier. So from scikit-learn to string, and then from the string you can convert to Earth Engine classifier. So this is basically a list of string. And if you come back to here, like, this is what we are trying to do. So you can uncomment this one and then just execute. This one is going to take some time. It's not going to be available immediately, so that's to keep that in mind. Because I already did that before, I might be able to just execute. Okay? I can just execute. But for if you're running this one for the first time, it might take you some time to be able to execute the next code block. So you might want to wait for a few minutes. You can check your Earth Engine account using the GE code editor to look at whether if this one is successfully executed or not. Once that one is in your account, then we can use that one just as any regular feature collection. So convert this one to a feature collection, and then from the feature collection to classifier. So you can see from this example in here, right? This is the step the same as this one that we used earlier. So convert the string to classifier, and then we can display the result. Okay, so you can see from here, it'll be the same because we haven't changed anything. We're still using the same training data and to classify the image. So lastly, I'm going to show you how to save the trees to your local computer. So you can either save this one directly to your Earth Engine account, or you can save this one locally. So it's a CSV, so keep that in mind. The tree basically is just a list of strings. We said 100 trees, so we're going to expect 100 rows in this CSV. So first, let's define the file path, and then we're going to use this function called trees to CSV. So if you execute, and then so this is because we are going to it's downloaded to the downloads folder, and right now if you see from here, it's already downloaded to the local drive, and you can double click and then you can open, right? So from here, like I said earlier, you should expect 100 lines, and this is what it looks like. The decision, the random forest is an ensemble of trees. So each one here is one decision tree. And so this one is already pre-trained. So in this way, we don't have to retrain the model. We can just convert this one directly to Earth Engine classifier. So this is the next step, is to CSV to classifier, right? And if you take a look, right now, basically we are reading the data from our local computer, reading this CSV, and then convert this CSV to Earth Engine classifier. Once we have the classifier, then we can do the same step. Okay, select the number of features and then pass in the classifier. FQ. And lastly, you can display the imagery again, right? So you can turn this one on and off. Okay, so this recap what we have done in this tutorial. So you can basically see we have 3 sections, right? We classify the imagery 3 times, but we're actually using the same classifier. So the first one is directly we train the model and then convert the model, the scikit-learn random forest, to a list of strings, and then we convert this one to Earth Engine classifier. Then we classify the image. And the next one is we actually save the model to the cloud, save the strings to the cloud, and then you can convert the string back to feature collection, and then from the feature collection to classifier. The last one is to save the tree locally, and then convert the tree, the CSV, back to a classifier, and then do the classification. So there are multiple ways you can do that. It depends on how you want to pursue. So if your data is pretty small, probably you can just use the first one just to train the model and then classify. But if you don't, if your model is a little bit larger than the one we are using in here, you can basically save the tree to a local computer as a CSV, or you can save the one to the cloud, and then you can load the data without having to retrain your model. Sometimes, because if you're directly using Earth Engine to train the model, if you want to have some modification, you cannot really do that. Everything is automated. But if on your local computer, you might be able to make some adjustment to fine tune your model, and then using the model to upload to Earth Engine to do classification. Okay, that's all for this tutorial. If you enjoyed this video, please consider hitting the like button and subscribe to my channel. Hope to see you in my next video. Take care. Bye bye.